So today we'll discuss about the types of motion rigid body can have. So in previous video we discussed that what is the rigid body, what is the actual concept of rigid body, right? So in today's video we're looking into that types of motion, like how many motion a rigid body can have, right? So let's start. So first, the motion which is basically translational motion, right? The first type of motion is translational motion, right? Let me hide this translational motion. Now basically what happens in this motion, basically every particle um erase it. No, it's can't be. Basically in this type of motion every constitute constitute particle have same displacement, right? They have same displacement. Every constituent particles, or you can say the every different particle every different particle have the same displacement. For example, consider like here is a point, there is a, like in this diagram there's a point 1, point 2, point 3, right? Now there's another 1, 2, 3. So they all have covered the same distance, which is from here to from here, right? They have covered the same displacement. So that is known as translational motion, in which when different particles of a body undergo same displacement, the motion of a body is known as translational motion. For example, consider that we are over here, we are having a rigid body. Over here there is a one rigid body, and over here we have another rigid body, and they both are identical, right? So consider the point A, point B, point C, point A, point B, and point C, right? And this is basically the road. This is what? This is the pathway. This is the road, right? Consider that this is point A, this is A dash, this is B, this is B dash, this is C, and this is C dash, right? And if we check the displacement over here, like from A to A dash, B to B dash, and C to C dash, you can see over here that they have covered the same displacement, right? If we join these lines, okay, my line is not like these, both are parallel to each other. I know my drawing is not very much good, but they both are basically, these both line up parallel to each other, right? So basically these 3 points A, B, and C, and this A dash, B dash, and C dash, they have all have covered same point, like same displacement. So the body, this rigid body is said to be in the transitional motion. Or you can see over here, like here the component of time was 0. This is component of time was 0, but when it will cover a displacement, like for example now the time is 2 seconds. Now the body, first the body was here, now the body is here. So the body has covered the same displacement, right? The body is covered, same displacement. So this type of motion is basically known as translational motion, right? So let's discuss another, and as we know that translational motion is basically divided into two other motions, which is basically like this. Translational motion is divided into two motions. First is like the circular motion, or you can say which is curvilinear motion. The curvy curvilinear motion, and second is rectilinear. What is rectilinear? Basically, in rectilinear, the body moves in the straight line, right? And curvilinear, the body moves in a circular motion. The body moves in a circular path. Oh, I'm sorry. The body moves in circular path, right? So that is known as curvilinear motion. Now we have another type of motion which is basically known as rotational motion, right? We have another type which is known as rotational motion. Basically, in this, the particle have same angular displacement, but it has different linear displacement, right? So in rotational motion, what happens basically, the particle have same angular displacement but different linear displacement. Now what does that mean? Basically, if you can easily understand this concept if you know the concept of angular displacement, and which basically this angular displacement is discussed in chapter number 4, and currently we are on chapter number 5, right? So for example, okay, here we have the example of this rotational motion over here. Okay, consider that this is a rigid body. This is a rigid body, right? I'm drawing this again. This is a rigid body, and it has moved from this point to like here. The t time was equal to 0. Now the time is equal to 2 seconds, right? And now it has moved from here, this point, right? So basically it has rotated, so obviously it will cover some angular displacement. So the angular displacement is this theta is the angular displacement between these points. This is point A, point B, this is B, this is A dash, B dash, right? This is angular displacement. Now if you see that point A and point B both have covered the same angular displacement, right? But there is a different linear displacement. Okay, let me draw a diagram over here so you can easily understand. Let me erase this. Okay, let's come over here. Okay, over here, let's draw a good diagram. Actually my drawing is not good, but I'll but consider that this is the fixed point, and the fixed point from the body, from a rigid body moves, is known as pivot point. So I'm writing over here P. This is known as basically pivot point, right? So from here we have a point which is point B. Now it has rotated, and here we have point B dash, right? And over here we have point A, and here we have A dash, and it has covered a angle, right? And the angle is basically the angular displacement, right? So over here, right, so you can see over here it has covered the same angular displacement, but obviously the linear displacement is changed for the both points, point A and point B, right? So we can write over here that B and B dash is not equal to A and A dash, right? So this is an important thing which you have to keep in your mind, right? So here the angular displacement is basically same and the linear displacement is changed. So that type of motion is known as rotational motion. So I hope this is clear to you. If you have any kind of queries, you can ask me in the comment section, and I would be really glad to answer you guys.